Welcome to Framework, the podcast that makes the NIST cybersecurity framework practical, engaging, and accessible. Whether you're a cybersecurity professional, business leader, or simply curious about how organizations defend against cyber threats, this series is for you. This podcast is inspired by a comprehensive guide to the NIST Cybersecurity Framework 2.0, a best-selling resource written by cybersecurity expert Dr. Jason Edwards and trusted by professionals worldwide. In each episode, we'll leverage a few insights from Jason's extensive book to dive deep into CSF 2.0, unpacking every function, category, and subcategory with real-world applications you can immediately use. If you're enjoying this episode and want to learn more, head over to cyberauthor.me to grab your copy of the book and access additional resources to enhance your cybersecurity journey. You can also visit baremetalcyber.com, where over 2 million people last year explored expert insights, articles, and practical tools across a wide range of cybersecurity topics. ID.AM-03, maintaining an inventory of data assets. ID.AM-03 ensures that organizations maintain a structured inventory of data assets, tracking sensitive, critical, and operational information across systems, networks, and storage environments. This subcategory belongs to the Identify function within the National Institute of Standards and Technology Cybersecurity Framework, version 2.0, emphasizing that organizations must know what data they possess, where it resides, and how it is managed to ensure its protection and compliance with security regulations. Without a well-maintained data asset inventory, organizations risk data mismanagement, security gaps, regulatory noncompliance, and increased exposure to data breaches. By maintaining an inventory of data assets, organizations ensure that they can classify, secure, and control access to sensitive and critical information. A structured data asset management framework enables organizations to track data ownership, enforce retention policies, and implement protection measures based on data sensitivity and regulatory requirements. Organizations that adopt automated data discovery tools, integrate classification frameworks, and continuously update data inventories improve their ability to detect unauthorized data access, enforce compliance controls, and optimize data lifecycle management. Multiple stakeholders play a role in maintaining a data asset inventory. Data governance teams and compliance officers are responsible for defining classification structures, enforcing retention policies, and ensuring regulatory compliance. IT administrators and cybersecurity professionals ensure that data asset inventories remain up to date, protected from unauthorized modifications, and integrated with security monitoring tools. Business unit leaders and system owners play a critical role in tracking data flows, identifying business-critical information, and ensuring that data management strategies align with operational needs. A well-maintained data asset inventory is implemented through automated discovery, classification, and real-time monitoring mechanisms. This includes deploying data cataloging solutions, enforcing metadata tagging for structured and unstructured data, and integrating access control policies that align with data sensitivity levels. Organizations that fail to implement structured data asset management strategies risk losing visibility over sensitive information, making data security enforcement inconsistent, and increasing the risk of unauthorized data access or accidental exposure. Several key terms define data asset management and its role in cybersecurity governance. Data discovery ensures that organizations automatically scan systems and networks to identify and classify all stored data assets. Data classification ensures that organizations assign sensitivity levels to data based on regulatory, operational, or business requirements. Metadata management ensures that organizations apply structured tags to data assets, enabling efficient tracking and policy enforcement. Data lifecycle management ensures that organizations define retention, archival, and disposal policies for data assets based on their value and regulatory constraints. Access control enforcement ensures that organizations apply role-based restrictions to data assets, ensuring that only authorized users can view or modify sensitive information. Challenges in maintaining an inventory of data assets often lead to incomplete visibility, misclassified information, and failure to enforce proper security measures. One common issue is lack of automated data discovery, where organizations rely on manual inventory tracking, leading to outdated or inaccurate records. Another issue is failure to classify unstructured data, where organizations do not track files, emails, or cloud-stored documents, increasing the risk of data exposure. Some organizations mistakenly believe that data asset inventories are only relevant for compliance audits, without recognizing that an up-to-date inventory is critical for incident response, threat detection, and operational efficiency. When organizations implement structured data asset inventories, they reduce security blind spots, improve data governance, and enhance the ability to protect sensitive and business-critical information. A structured data inventory model ensures that cybersecurity teams enforce real-time data tracking, business leadership prioritizes data classification efforts, and IT security teams integrate automated discovery tools into ongoing cybersecurity operations. Organizations that adopt machine learning-driven data classification integrate inventory tracking into security information and event management (SIEM) systems, and enforce continuous monitoring of data flows, develop a comprehensive data asset management strategy that strengthens resilience against data breaches and unauthorized access. Organizations that fail to maintain an inventory of data assets face significant security, operational, and compliance risks. Without structured data asset tracking, businesses risk losing control over sensitive information, making it difficult to enforce security measures or comply with regulatory requirements. A common issue is shadow data, where organizations store, process, or share sensitive information without tracking its location, access, or security posture, increasing the risk of accidental exposure or data leaks. Another major challenge is inconsistent data classification, where organizations fail to define structured policies for labeling sensitive, critical, or public data, leading to mismanaged access controls and increased risk of insider threats. By implementing structured data asset inventory management, organizations ensure that all stored, transmitted, and processed data is accounted for, properly classified, and protected from unauthorized access or misuse. A well-defined data asset inventory framework incorporates automated discovery tools, enforces metadata tagging for structured and unstructured data, and integrates access control policies to protect sensitive information. Organizations that adopt centralized data cataloging platforms, establish role-based access management for stored information, and enforce real-time monitoring of data flows improve their ability to prevent unauthorized data access, detect anomalous activity, and enhance regulatory compliance. At the partial tier, organizations lack a structured data asset inventory, leading to inconsistent tracking and increased risks of data exposure. Data security and governance are reactive, with inventory updates occurring infrequently or only after security incidents. A small business at this level may store customer information across multiple locations, such as local computers, cloud storage, and external hard drives, without maintaining an organized record of where sensitive data resides or who has access to it. At the risk-informed tier, organizations begin to establish formal data asset inventory management practices, ensuring that data classification and ownership tracking are applied across critical business systems. However, security enforcement may still be inconsistent, with limited visibility into unstructured data and challenges in tracking third-party data sharing. A mid-size healthcare provider at this level may catalog patient records stored in databases but fail to track sensitive documents stored in cloud collaboration platforms, increasing the risk of non-compliance with privacy regulations. At the repeatable tier, organizations implement a fully structured data asset inventory framework, ensuring that all stored, transmitted, and processed data is continuously tracked, classified, and protected. Data governance is formalized, with leadership actively involved in defining security policies, enforcing data retention standards, and ensuring compliance with industry regulations. A multinational financial institution at this stage may use automated data discovery tools to detect and classify sensitive financial data, integrate inventory tracking with compliance dashboards, and enforce strict access control policies to prevent unauthorized data exposure. At the adaptive tier, organizations employ AI-driven data classification, real-time data inventory monitoring, and dynamic risk-based access controls to continuously assess and refine data asset management strategies. Data inventory management is fully integrated into enterprise cybersecurity governance, ensuring that organizations detect and mitigate risks associated with data sprawl and unauthorized access in real time. A global technology company at this level may use AI-powered analytics to automatically classify and tag data based on sensitivity, enforce just-in-time access policies for high-risk data assets, and implement self-learning algorithms that adjust security controls based on evolving data risk factors. Maintaining a data asset inventory aligns with multiple controls in the National Institute of Standards and Technology Special Publication 800-53, ensuring that organizations implement structured data governance models and proactive data security strategies. One key control is CM-8, System Component Inventory, which requires organizations to maintain an up-to-date inventory of all hardware, software, and data assets to ensure proper security oversight. A government agency implementing this control may use an asset management platform to continuously track classified information and enforce strict access controls to prevent unauthorized data exposure. Another key control is AC-3 access enforcement, which mandates that organizations apply structured access control policies based on data classification and security risk levels. A cloud service provider implementing this control may restrict access to sensitive customer data based on predefined access roles and continuously monitor login activities for signs of unauthorized access attempts. Maintaining an inventory of data assets also aligns with AU-9, Protection of Audit Information, which requires organizations to track and secure audit logs that record access to data assets, ensuring accountability and preventing unauthorized modifications. This control ensures that organizations log and monitor access to sensitive data, detect unauthorized activity, and maintain records for compliance and forensic investigations. A multinational healthcare provider implementing this control may use centralized log management to track access to electronic health records, ensuring that all user activity is auditable and aligned with regulatory requirements. These controls can be adapted based on organizational size, industry, and cybersecurity maturity. A small business may implement manual data tracking methods, ensuring that all sensitive information is logged and access is restricted based on user roles. A large enterprise may deploy automated data inventory solutions, AI-driven classification models, and continuous monitoring tools to ensure that data inventory security policies are enforced dynamically. Organizations in highly regulated industries such as finance, healthcare, and defense may require legally mandated data cataloging practices, compliance-driven data security audits, and strict governance models for managing sensitive data assets. Auditors assess an organization's ability to maintain an inventory of data assets by reviewing whether structured, documented, and continuously enforced data management frameworks are in place. They evaluate whether organizations implement automated data discovery, enforce classification policies, and integrate real-time access monitoring into enterprise security operations. If an organization fails to maintain a structured inventory, auditors may issue findings highlighting gaps in data visibility, weak alignment between data asset tracking policies and compliance requirements, and failure to integrate structured data governance into enterprise security frameworks. To verify compliance, auditors seek specific types of evidence. Data classification policy documentation and structured inventory reports demonstrate that organizations formally define and enforce data asset tracking standards. Access control logs and security incident records provide insights into whether organizations proactively monitor data access and detect unauthorized attempts to retrieve or modify critical information. Automated inventory update reports and predictive data governance analytics show whether organizations effectively track, monitor, and refine data inventory strategies using real-world risk assessments and adaptive security controls. A compliance success scenario could involve a global financial institution that undergoes an audit and provides evidence that data asset management strategies are fully integrated into enterprise cybersecurity governance, ensuring that all stored, transmitted, and processed data remains accounted for, classified, and protected. Auditors confirm that data inventory policies are systematically enforced, asset tracking mechanisms are dynamically updated, and enterprise-wide cybersecurity governance frameworks align with structured data management requirements. In contrast, an organization that fails to implement structured data asset tracking, neglects real-time classification updates, or lacks formalized access control policies may receive audit findings for poor data visibility, weak governance enforcement, and failure to align inventory management strategies with regulatory compliance mandates. Organizations face multiple barriers in ensuring that data inventory management strategies remain continuous and effective. One major challenge is lack of automation in data discovery, where organizations struggle to keep up with the rapid expansion of data assets across cloud, on-premise, and hybrid environments. Another challenge is failure to enforce data classification, where organizations store unstructured data without proper categorization, making it difficult to apply security controls consistently. A final challenge is over-reliance on periodic manual audits, where organizations fail to implement real-time monitoring, increasing the risk of undetected data exposure or unauthorized access. Organizations can overcome these barriers by developing structured data inventory management frameworks, ensuring that asset tracking policies remain continuously optimized, and integrating real-time data governance models into enterprise-wide cybersecurity strategies. Investing in automated data discovery tools, predictive asset classification analytics, and AI-driven risk assessment models ensures that organizations dynamically assess, monitor, and refine data inventory strategies in real time. Standardizing data governance methodologies across departments, subsidiaries, and external business partners ensures that data inventory security policies are consistently applied, reducing exposure to unauthorized data access and strengthening enterprise-wide data management resilience. By embedding data inventory management strategies into enterprise cybersecurity governance frameworks, organizations enhance data security risk awareness, improve regulatory compliance, and ensure sustainable data tracking processes across evolving cyber risk landscapes. That wraps up today's discussion on framework. Don't stop here. Head over to cyberauthor.me to explore more cybersecurity topics and discover a best-selling book covering NIST and other critical cyber frameworks. Please like, rate, and review this episode on Apple and Spotify. Until next time, remember that knowledge is power.